Hello again, everybody. This is Mr. Wakefield looking at what we call solving formulas for a specified variable. Basically, this is a very similar thing to solving a one-variable equation, with the obvious difference from when you look down here. It doesn't look like it's a one-variable equation. It looks like you have a whole bunch of variables because letters usually are variables, right? So, as it turns out here, when they ask you to solve a formula for a specified variable, and for example here, that specified variable is r. In this problem, it's m right here, they tell you at the end. Okay. You need to pretend like the other letters are constant numbers. Okay, it doesn't mean that you need to actually replace them with constant numbers. In fact, don't do that. But you kind of pretend like they're constant numbers. So it's kind of like here you could pretend like that's a 12, for example, and the P right here is a 3, and the R is a 2. Again, just don't do 0 because that creates a whole different situation. But if you want to pretend like these are constant numbers, you could do that. You should think of it that way, actually. And then that will give you a perspective on what steps to do. And I'll obviously help you out here with that as well. It says here, since the formulas in this section are linear, they put that in quotes because it's not the same as the one variable linear equations because they only have one letter in them. But it is still the same idea. This is a worksheet from a different video where we learn how to solve a one variable equation. We're going to do these same steps here for the most part for that reason, because it is the same type of thing. The only difference again is that it has more than one letter in these equations that we're looking at now, but we're supposed to pretend like those other letters are constants. So the R right here, and I stand corrected a few minutes ago. I said that the R was I was pretending like it was a constant. We're actually supposed to pretend like the I, P, and T are constants, okay? Because the R is the variable. So you could pretend like the I is 12, and the P is a 3, and the T is a 2. And then you need to get, the point is you need to get the R by itself with the same steps that we had for linear equations. And the reason why we use those steps instead of the steps from other types of equations that we'll learn later is because if you pretend like the other letters are constants, these equations look the same as the equations that were linear equations, where after you clear out the parentheses, you just have x is not x to the second or x to the third or anything. You just have normal terms being added and subtracted together. Okay, same idea here. Okay, notice the r, and then that's your variable, and then you have r to the first, and these are just two normal terms. Yeah, they got a lot of letters, but they're still in that same format as the monomial terms that we learned about before, which comprise a linear equation. Okay, yeah, they don't have the exponents in them like these examples do, but they still have that same format where you have a variable being multiplied by constants here, and it can be more than one. That still is equivalent, all right, to a monomial term. So the point is that when you have terms on each side, and it could be just a single term on each side, or it could be terms being added and subtracted together, even after you clear out the parentheses here. If the variable that is designated is just, for example, m, or if it's just r, it's not r squared or m squared. If you don't see anything like that in the equation, okay, then that's going to be a linear equation. And even after I distribute out this 4 right here, you'll only see m's. You won't see m to the second or m to the third. You won't see r to the second. Down here, w is the variable that's designated. See how you see right here, w, not w to the second or w to the third. That's why we say that they are essentially linear. And so we can follow these same steps, okay, that we had for solving linear equations. Okay. And so, how would we go about that then? Well, if you look at just a review here, if you look back at solving linear equations, after you clear out any parentheses that you have in this first equation, doesn't have any, and then combine like terms. Again, there are no like terms here to combine. you then designate what your variable and your constant terms are. Okay, I did the variables in red and the constant numbers in green. Again, you don't have to use the color there, but that just helps me, or helps you see better what we need to do with those terms. Okay, because you need to move the variable terms on one side and the constant terms on the other side. We did that, okay, where we moved the variables to the right and the constant terms to the left over here. Now, in this problem, however, this one's a little simpler than that because you already have a variable term, and I'm putting this in red because it has the designated variable in it, r. Okay, so if that designated variable is in a term, okay, then that means that that's a variable term. So just like I did in that other video that I'm reviewing with you right now, the red means a variable term, the green means it's not a variable term. So even though this is a letter, it doesn't have the designated variable in it. So we treat that like a constant term, even though it doesn't look like one. That's what I was saying earlier. Pretend like that's a 12 or something like that. Okay, it just kind of helps you visualize how it's similar to the linear equations that we've done before. Okay, now, how do we go about getting r by itself? When you solve an equation for a variable, which it tells us to do here, this is an equation because of the equal sign. I know it's an equation. We're solving for a variable, like it tells us. It means to get the variable by itself. When you have a single term, one variable term and one constant term, okay, it's just like right here where you had a single variable term and a single constant term. When you have a single variable term on one side and a single constant term on the other side, that's the step where you what? That's the step where you divide out. Okay, so that's exactly what I'm going to do here. This looks a little bit different than before in that other worksheet that I just showed you, but when you have three things being multiplied together, you guys, and you want to get one of the three things by itself, here's what you do. You divide by the other two things, but you got to say that they're being multiplied there, okay? Otherwise, they won't cancel, okay? You got to say that they're being multiplied like that, and then that gets the r by itself. Now, if you divide one side by pt, then you have to divide the other side by the same thing as always. And so we end up with I divided by pt. Okay. And so that's the idea right there, okay? So again, the linear steps say to what? They say to clear out the parentheses first, and then after that, there's not, these problems typically don't have any like terms to combine because of all the letters and stuff. So you can usually move past the second step. So clear out any parentheses like we will in the next problem. And then you do that thing where you move the variable terms on one side and the constant terms to the other. Okay, where we highlight the red and the green, and we make sure that the red is on one side and the green is on the other. Let's do that here. Okay, so let's clear out the parentheses first. 4 times m minus 4 times b. Okay, now there's no like terms, at least not on each side individually, okay? But we can move on to the next step where we move all the variable terms to one side. There's the variable terms right there. And then the terms that don't have the designated variable in it, the designated variable is m. Any term that doesn't have the variable in it, remember, terms are things that are what? That are being added and subtracted. So that's why we have a total of 5 terms here. Okay, 2 on the right side of the equal sign because of the plus in between it. And then 3 over here because of the minus and the plus in between those. So what we need to do is we need to move the 2 red ones to one side. You can pick which side. And then move the 3 green ones over to the other side. I'll go ahead and move the red ones to the left-hand side, just to pick a side, like this. And what do we get here? We get negative 2m, and then all the green ones haven't been moved yet, so we'll keep those the same. All right, then you need to move the 2 green ones over with this green one. Since you have 2 of them to move over, you can move them both over at the same time using the same method as normal. Okay, because this is minus b, you got to add 4b. That'll make it cancel. Because this is positive n, you've got to subtract n. That'll make that cancel. And it'll just leave me with negative 2m on the left-hand side. Over here, I need to do the same thing. So since I added 4b and subtracted n, I need to do the same thing over here. Now remember, you guys, these three terms are not like terms. Okay, so don't try to combine them together. Okay, I know usually when we move terms from one side to another in an equation, we usually combine the like terms. Okay, and we're used to combining terms because usually you have like terms. For example, when you moved over the, say in this example right here, you moved over the 2x, you got the 4x here, and then when you moved over the 1 with the negative 3, okay, you were able to combine that. Okay, they usually combine, okay? They don't always. These do not combine because they're not like terms. It's okay that it's that way. What's important, you guys, I know I said before that if you have a single red one and a single green one, you can divide. But what's really true, it's just that we've never run into this before until now. What's really true is that if you have a single variable term, even if you have a bunch of constant terms on the other side, that's okay. As long as you have a single variable term, that's what allows you to divide out to get the m by itself. If you have a single variable term, okay, then you can divide by the negative 2 to get the m by itself. So even though there's a whole bunch of stuff over here, not just one term, that's okay. Because you'll still be able to get the m by itself, and that's the most important thing. Okay, let me go ahead and rewrite this equation up here where I can do some work here on it. So I need to divide by negative 2, so the negative 2's will cancel. Divide over here. Now the answer is kind of bigger than it would normally be because of all those terms. C, 4b, and negative n, but still, you got m by itself. Remember, and let me remind you, if you don't remember, the goal when you solve an equation for a variable is to not only get the x by itself, but so that the x, or whatever variable is designated, is not on the other side. Okay, see how you got x by itself, but it's not on the other side. If you had x equal to 2x minus 3, that doesn't count. Yes, you got x by itself, but you can't have the variable on the other side, otherwise the variable is not really solved for. So my point here is this, okay, if you get the variable that's designated by itself, and it's not on the other side, see how there's no m over here? You have truly solved for that variable, and you are done. And I mention that because in this problem, a lot of students make the mistake, as I go over here to problem C, a lot of students, because of the fact that there's two terms with the w in it, a lot of students will just get one of the two terms by itself, divide out, and then they'll end up with a w. They'll end up with w by itself, but they'll end up with w on the other side of the equal sign also, and that's not going to work. Okay, you can't have the variable on the other side. So there's another way to solve this here besides that. Okay, I'll show you that. But mostly it's still the same steps. It's not something completely brand new. Okay, there's no variable, I'm sorry, there's no parentheses in this problem. And so just like we talked about, okay, clear out the parentheses. There's usually not going to be any like terms. Okay, so you just go right to the step where you need to move the terms that have the variables on one side and the terms that don't have the variables on the other side. The two green ones here are green because they don't have w in it. So I need to move those two to the opposite side of where the red ones are. Those cancel right there. You can go ahead and just keep the two red ones right where they're at because they need to be on the same side anyway, so might as well just keep them right where they are because they already are on the same side. Remember again, do not try to, when you are adding or subtracting terms, and that's why I said the same thing over here, C plus 4B minus N. When the terms are being added and subtracted, don't try to combine them, keep them separate when they're not like terms. These are not like terms either, and since they're being subtracted, okay, we keep them separate like this. And then what's left over here is 2LW plus 2WH. Now this is kind of rare. We will see it again in one more problem down here, number 2. Okay. But when you have two terms, assuming that you've gotten the variable terms on one side and the constant terms on the other, if you have more than one term with the variable in it, the variable that's designated, that's a little bit different. You can't just divide out yet. There's one additional step that you have to do when there's more than one term with that variable in it. Okay, here's what you got to do. You have to factor out, okay, the W out of these two terms. Okay, just like when you factor out a greatest common factor. Okay, if you factor out the W, since W times 2L is equal to 2LW, factoring out the W is, again, I'm not saying the W is the greatest common factor. That would actually be 2W, but we only want to factor out the W. Okay, you'll see why here in a second. It'll help us get W by itself. But factoring out the W, you get W times 2L, matches up with that. And then W times 2H, positive 2H. If you multiply that out just to check to make sure you're factoring it correctly, okay, that gives you 2WH. And so you can see that this is correct here. This is equal to this up here, but you factored out the W outside of that bracket. Okay, so it's similar to doing a GCF problem, even though W is not the GCF, the greatest common factor. What you do now, though, and here's why this works. Once you do that, you then divide by the bracket. You don't need to write the bracket down here. That's okay, because that's the only thing that's down there. It's not being multiplied or added to anything down there on the bottom of the fraction. So you can just do that. That cancels out, and you get W by itself. But whatever you divide on one side, what do you got to do, you guys? You got to divide it on the other side as well, right? So the 2L plus 2H that I just canceled, that's got to be divided over here as well. Let me just write the answer over here so you can see it. The answer is going to be what? It's going to be A minus 2LH over 2L plus 2H is equal to W. We got W by itself. Notice that the W is not on the other side either. So you have truly solved for W right there. W by itself, W not on the other side, W is truly solved for. Okay. Next problem here has a fraction in it. Okay. I want you to notice something though. When you have just simply a fraction on one side of an equal sign, and then you have just a normal term on the other side, you can think of that term as a fraction also, s over 1. And I do that because when you have a single fraction on each side of an equal sign, you can cross multiply. Not cross cancel, but cross multiply. Okay. Got to put a bracket around that when there's more than one term. Whenever you multiply something that's more than one term in it, I got to multiply that denominator by the s. I've got to cross multiply this denominator times this numerator. This denominator times this numerator. Again, you're allowed to do that when you have just a single fraction, nothing else, on each side of the equal sign. But you got to bracket that because it's got more than one term and you're multiplying it by something. Okay. Once again, when you have something with more than one term and you have to multiply by something else, you've got to bracket that thing that has more than one term in it. And when you're multiplying denominator times numerator, you have to multiply the entire denominator, not just part of it. So you got to bracket that because that entire denominator has more than one term. Here you've got 1 times A, which is just A. And so now I've got something that's kind of similar to this problem up here. It's a little bit smaller, but you have a bracket. So we need to clear out that bracket first. S times 1 is S. S times negative R is negative SR. And now, once again, once you clear out those parentheses, let's designate what our variable terms are. This one has the designated variable R in it. The other two terms, S and A, And I know there's a total of 3 terms because the minus separates this into 2 terms on the left side of the equal sign. Here you've got no pluses or minuses, that's just a single term. So then, now that I've done that, I now realize that I need to get the 2 green ones on the opposite side of where the red one is. And so I get this right here. Again, don't combine those because they're not like terms and they're being subtracted. Remember, adding and subtracting terms cannot combine them unless they're like terms. Multiplying and dividing is a little bit different. Okay, so now I have what? Now I have, again, a situation where I have a single variable term on one side, okay, and multiple constant terms on the other side. Just like in this problem up here, that's okay. As long as you have the single variable term, you guys, okay, you can divide out and get the variable by itself. It's okay to have a whole bunch of constant terms over here, just so long as the variable is not over here, okay? Which is why we move the variable terms to one side and the constant terms to the other, so that the variable will be separate on one side. So then we need to divide by negative s, right, in order to get the r by itself. Those cancel, and you get r is equal to a minus s over negative s. So once again, we got r by itself, the designated variable. It's not on the other side. We have truly solved for r as they asked us to do. So to review here, clear out your parentheses first. Designate, you don't have to use the color here, but you designate, make sure you know at least in your head which ones are the constant terms and which ones are the variable terms. Separate them on different sides of the equal sign and then divide out. If you have 2 variable terms, like we saw in problem C, okay, after you've moved the reds to one side and the greens to the other side, if you still have that like we do here, then do this thing where you factor out the variable first, then divide by the bracket. That will then get the variable by itself. You'll see that in problem number 2 right here. The only difference between problem number 2 and problem C is that here h is the variable, okay? So here's the variable terms right here. And then the constant terms are these ones right here, right? Okay, because they don't have the designated variable h in them. Okay, I'll go ahead and let you guys try these 4 problems here. Just go ahead and turn off the video here for just a moment. Give them a try. We'll look at the work and the answers coming up. Let me just fill you in on a few things though first. Again, this is very similar to this one. Problem 2 is similar to problem C. Very, very similar. Go and give that a try. Notice in problem number 1, okay, the designated variable is y. All right, so that means the middle term there is the red one. The other 2 are green because they don't have y in it. All right, don't be thrown off by that t squared right there. I know I said that in linear equations you don't have variable squared, but remember the t is not the variable here though, because a is the variable that they designated. So the t squared, that's just like a normal constant number, okay, even though it has an exponent there. So the way you look at this one is that this is the variable term because it has the a in it, but the t squared is not part of that variable though. It's the a that's the variable. So you want to get the s and the vt on the opposite side of where the at squared is so that you can ultimately get a by itself. In problem number 4, do the same thing that we did in problem D, cross multiply first, and then it'll be very similar to that. Treat this as if it's I over 1, cross multiply, and then we'll go from there. We'll go ahead and take a look at those answers here in just a moment. So go ahead and pause the video, give it a try, and then let's see how you do. Okay, so as we were talking about, when you have 2 constant terms that are not on the same side, we need to get them on the same side, the opposite side of where the red term is. And so we do that by adding and subtracting. Since ax is positive, I need to subtract it over. And so that's what I did right here. Okay, I subtracted it over. Remember, these are not like terms, so don't try to combine them. Just say that they're being subtracted. And now that we have the green term on one side and the red term on one side, the green term on the other side, then that means that we now need to divide out to get the y completely by itself. And so your final answer is right there. C minus ax over b is equal to y by itself. Over here, again, this is very similar to problem C up above. Okay, we have the red ones on one side, the green ones are not on the same side, but they need to be put on the opposite side of where the red ones are. And so I need to subtract that 2L over to the other side. And you can see I did that right there. Again, not combining these terms because they're not like terms. Okay, and then because you have two red terms, you need to do that thing that we did up here. Okay, where you factored out the designated variable. Up here, the designated variable was w, so we factored that out. Here, the designated variable is h, and so we factor out the h, like you can see I did right here, h, and then 2L plus 2W. Pretend like I haven't canceled yet here. 2L plus 2W is what's on the inside after you factor out the h right here, just like factoring out a GCF. And then you divide by 2L plus 2W, very similar to what we did up here in problem C. And then we get this answer right here where h is by itself, and you can see it right there. Okay, so that's problem number 2. Okay, again, very similar to problem C. Okay, let's go down here to problem 3. Once again, we have the red one and then two green ones that are not on the same side, so we need to get them not only on the same side, but the opposite side of where the red one is. So I subtract the VT over so that the green ones will be on the left, the red one on the right. And then since A is being multiplied by t squared, we divide by t squared, okay, and that gets the A completely by itself. And there you go. Okay, so that's number 3. And in number 4, okay, as we mentioned up in problem D, okay, when you have a fraction on each side, you can cross multiply in order to make it look like a normal equation that we've been doing here in this worksheet. You have to distribute out your parentheses before you do that red and green thing. So I did that right here, I big R plus I little r. Once again, we have a red and a couple greens. We see that a lot, okay? So the green ones need to be moved on the opposite side of where the red one is. Okay, again, since IR is positive, you subtract it over. If this had been negative IR, you'd add it over, for example. Just a reminder there. Then we need to divide out the I, okay? And so we get this right here, okay? As we learned in a previous video, do not cancel the i's right here because there's two terms up here separated by the minus sign. So the only way you could even think about canceling is if you factor the top here, since it has more than one term, and then try to cancel. I'm not requiring you to do that though, so you could stop right here. I just wanted to remind you of why you can't cancel the i's. It's because there's two terms on the top. Okay. So anyway, that concludes our worksheet on solving formulas for a specified variable.